All right. Thank you so much, Meredith. And thanks to everybody who's joining us today. And please do, as we get started here, introduce yourselves in the chat. So it's my pleasure to introduce Anna Liljedahl today. Anna is with the Woodwell Center, where she is an associate scientist, but also an affiliate professor at University of Alaska Fairbanks. Also, Anna is one of the co-leads for the risk management and hazard mitigation team here at IARPC. And she's going to be telling us today about the Permafrost Discovery Gateway. Just really quick, I'll let Anna introduce herself through her work, but really impressive productive history and kind of hard to describe what she does on an everyday basis. I guess if you had to make up a term for it, it'd be something like permafrost hydrology, but really it's more about understanding interactions between the cryosphere and the people who depend on the resources in Alaska and the Arctic. So with that, I'll hand it off to Anna, and thanks so much for talking to us today.
Thank you very much, Steve. Appreciate it. Yes, I started off in the field on the tundra doing hydrology research, and now I'm really into doing big geospatial data with a broad range of collaborators here. So I'm representing a team here today, the Permafrost Discovery Gateway team, and we are building this free map toolbox to empower all Alaskans. And we really want to bring you the big geospatial information here. So first, I wanted to introduce the leads here in the team. So we have I have seven co-PIs with me, and it's Shandavi Tharana at University of Connecticut, remote sensing, and Kenton McHenry and Luigi Marini at University of Illinois. And they are really offering software engineering and big computing support. And Helene Genet at University of Alaska Fairbanks with her carbon modeling expertise. And we have Micah Brubaker, Sarah Yoder, and also Rebecca Arnold at the Alaska Native Tribal Health Consortium and also the Alaska Pacific University. So they're bringing in the linkage to our communities and the Leo network in particular. And we have Wen Lee. She's with Arizona State University, and she's helping out bringing in AI for interacting with the big data. And Guido Gross and Ingmar Nitze at Alfred Wegener Institute. So they are bringing in big power in regards to generating big permafrost data. And then Matt Jones, who is also here today with us, he is the director of the Arctic Data Center, and that is the home of the Gateway, as you'll see. And the cyber infrastructure we're building can be used for any domain, and permafrost is our focus for this today. And I also want to thank our Google Fellows that worked with us for 6 months in January to June 2024. So we had over 10 full-time software engineers helping us out and guiding us in steps ahead. So Alaska, I'm just bringing you back to the big picture and motivations here. So if I remember right, Leslie Jones at State of Alaska, she pointed out earlier this fall that Alaska has a D- in terms of the grade it receives in geospatial information readiness. And at the same time, we have more data than ever available to us. And as an example, here is the high resolution optical imagery from Maxar that's housed at the Polar Geospatial Center. It's increasing year after year. And another thing we have going on right now is we don't really have any excuses anymore to saying that we have limited access to information in terms of internet speeds, because Alaska is having access now to an internet that's becoming available around the globe. And here's us doing field work in the Arctic National Wildlife Refuge, being connected to the high-speed internet. So the timing is really, really exciting. And at the same time, we all are walking around with our data gathering gadgets with our smartphones. So take that all together, collaboration is becoming limitless and lots of opportunities ahead. And hosts such as those you see at the Leo network here on the right, anyone can do observations in their backyard. So we are in exciting times right now and also ahead of what we can learn and how we can work together and address challenges. And these arrows are all pointing in different directions. I wanted to make the point that the data can bring us together, and we can choose what direction in the exciting times, the exciting paths that we're exploring. So for people that have a common interest, let's say it's coastal erosion, or maybe it's coastal erosion around Noatak, or maybe it's coastal erosion that's measured by drones. These kind of topics, these themes can bring together people that have common interest, and therefore varying kinds of knowledge, complemented knowledge can connect over these common interests. So if we can help people find each other through their common interest, I think wonderful things can happen. So the Permafrost Discovery Gateway, it's a free online platform. It's available via a regular internet browser. And that's a place where people, no matter their technical or financial resources, can access and explore and use big geospatial data. So we really focus on the big geospatial data. And what I mean with that is most people, if they try to upload the data sets into their own computer, it wouldn't fit. Or if you try to put it into your ArcGIS would crash. It's sub-meter data across Alaska, across the Arctic. And while we're focusing on being able to make that data, to create that data and to make that data accessible, that big geospatial data becomes really interesting and useful if we combine it with other data. And that could be, point observations, photos, regular, field measurements of time series and so on. So bring different kind of data together in the years ahead. And you can go and explore it right now at Permafrost at arcticdata.io. And we have 2 more years of funding from google.org to work on this, but we have ideas for many more years than that. And so permafrost is the topic, the domain that centers the data, gives the gateway a focus. If you like glaciers, you could use the infrastructure we built up and call it the Glacier Discovery Gateway too. So it's open source and available for that. And you can develop this portal directly as you submit your data at the Arctic Data Center. And in particular, what makes permafrost interesting, I think, is that we have some areas where permafrost is very ice rich. Up to 70% of the top 3 meters, so the permafrost can be, 70% can be ice. And here's a photo from the Corral Permafrost Tunnel in Fairbanks with these beautiful ice wedges that are just ice. And that makes permafrost thaw challenging in regards to infrastructure. So here is a photo, Point Lay from Ben Jones' write-up showing, before and then after a house was built and the road, more roads were put in. So putting in roads, putting in infrastructure disturbs the landscape as well and cause complications if we're not careful on how we design and our structures. And we have 5 million people living in the Arctic, and a paper by Hjort and others, they pointed out that at least 50% of Arctic infrastructure is at risk within the next 25 years. But I think we all know here that it's already a problem. People are already dealing with it, as evident of this photo here. So it's not just a future problem, it's already here. So I wanted to tell you a bit some about the discovery tools we are developing here. And why do we need discovery tools? Yeah, because we can increase data access, remove the technical and financial barriers. We can increase the freshness of information. So that means that we can look at shorten and also automate the pipeline for data generation, making the data available. So instead of looking what happened 10 years ago, we can see what happened last month. And also these discovery tools can help make science more collaborative. We can connect people by connecting the data and also bring together knowledge. And in the end, hopefully also make the science product academic communities producing, make it more useful for the on-the-ground challenges. So I wanted to give you some examples of tools that we already have active, and that is location search. So you can go on there and put your coordinates, your name, and the gateway will take you there. And we also have a design of a legend. So have created some groups, some themes, like people and infrastructure and lake and water, and that can be added to or changed as we move forward. And also you can see the different, what they call different color means here in the different layers. And we have a zoom to feature with storytelling. So if you go to a specific community, you can get a highlight of what people have observed in that community in terms of permafrost. So you can have an idea of how people are living and what that could look like. Experiences around permafrost. And then we also created from the feedback of our surveys. Thank you. Several of you here have helped in the interviews and given us feedback. We created this shareable URL. So if you create a certain combination of map layers and zoom in location, you can share that exact view with whoever, with your friend or colleague. Here. And we have more features in the work too, and they are all developed with input from end users, because this is a very important step, and I think Google, collaboration with google.org, really helped us emphasize the value of interviewing people, doing pretend displays of the web page, and then hear people's thought of what worked and what didn't work, and before we even implement it into software, we got the thumbs up from the people who we are seeing as the users that we want to reach. So very, very valuable to have that. I wanted to give you some examples of what kind of big map data is available and being created as well. So we have focusing on monitoring permafrost thaw across Alaska and the Arctic. So we have the ice ridge polygon map that Shandi Vitharana and team generated. So we mapped ice ridge polygons, each individual polygons, as you can see, down in the right. And where we have them, we have these ice wedges that are ice-rich permafrost. And that map exists for the Pan-Arctic region, so where we have no trees. It's hard to see the polygons where we get trees. And it's over 1.8 billion ice wedge polygons across the Arctic that we counted. And that's definitely an underestimate. There's more of them that we can't see from optical imagery. And also a retrogressive thaw slump map. So these erosional features release a lot of sediment and can live on and grow for several years, so affecting water quality and so on. And so Ingmar Nitze and his team at Avi, they mapped it from planet imagery and some bigger region across the Arctic here. So this is a preprint paper that's available, and the data set is also available. We don't have it uploaded on the gateway just yet. It's in our big waiting line for data sets to add. But here's individual thaw slumps that are mapped from 1 year to the next. Very exciting data sets from 3-meter resolution or imagery. And Elias Manos, a PhD student with Shanti Vitharana at University of Connecticut, he has mapped infrastructure from the Maxar 0.5 meter resolution imagery of Alaska, and showing buildings and tanks and roads. And he's also working on doing this Panarctic as well. So this is a step up from the OpenStreetMaps that is available. So that this data set will become available on the Gateway here this winter. And another exciting thing that's in the works is creating this automated workflow that maps lake drainage near real time. And with that, I mean, as soon as an image become available, and that would be at least once a month in the summer, or maybe even twice a month, using Sentinel imagery. And because right now when we're looking at drainage events, we look at what happened a decade or so ago, but we can do better than that and be on top of it. So right now, Shen Wang is leading the workflow, and Ingmar is supporting with the science part. And then Kyla Hardy at Google was the one who's got us started, and then Matt Jones and his team will finish off this resource by creating the visualization, automated transport of these data sets, these products into the visualization, so you can see it on the Gateway. So we're hoping to have this for you for next summer, so you can see in June and in July and August what lakes have drained across the Arctic. And some tools also we're generating to make this big data easily to understand and work with is, for example, we have the iceberg polygon data set across the Arctic, and you can see in yellow where the polygons are, but that's about it. So one thing we're creating for these big data sets with the help of Wen Lee and Matt Jones is do this summary data set. So if you're looking at the whole Arctic, you can see what's the percent coverage, for example, of iceberg polygons, and or what's their average diameter, how does it vary across the Arctic. So you can zoom in and zoom out and get these statistics or the summary presented to you. And another tool is collaboration with Mike Brubaker and Wen Lee is to integrate AI into the background of mining the internet from stories of permafrost, and to really improve that search, and so that observations, whether it's from people making posts on social media, or if it's new stories coming up, that can be gathered and collected, because this type of data is so valuable and complement this big data so well. It gives these stories gives a reality check to the otherwise kind of maybe abstract big geospatial data sets. So valuable to incorporate. And another tool that is in the works, and we're looking for people to try it out. So some scientists, if you know of a graduate student or postdoc or whatever, who is interested in using AI for mapping features in the landscape. Could be caribous, it could be coastal erosion, could be pingos, you name it. Vishu at NCSA, he has created this module. It's a one-stop solution to both train and run your machine learning feature detection workflow. So this is to try to make this technique, this approach, machine learning, more accessible to more people. And so we're taking the workflow that Shanti Vitharana built, where he has resolved how to run analysis across big scales across the Arctic, so that people don't have to reinvent that aspect of the code. They can just bring in their own algorithm showing, mapping coastal erosion, for example, and make it work across the Arctic. Try it out at different places in the Arctic, and then eventually run it across the Arctic. So really lower the barrier for big data generation, make that more accessible for people. And Jennifer Moss at UAF, she is building lesson plans for K-12 students and up this coming year. And already we got a really fun virtual tour of the Corral Permafrost Town that you can go and do. And with these headsets as well, works really well. And Wen Lee also is leading a project on Cyber 2A, where we just had a workshop in person for about AI for Arctic research, and there's an online course book that is available and being improved upon here in the coming months, so anyone can go and learn how to incorporate AI for their Arctic research. And lastly, I wanted to bring up that we're also looking for more people to take the time to talk with us for an hour over Zoom, and where you tell us what you would like to see in the gateway. So especially in regards to permafrost thaw hazards in communities. So here, for example, is a map of ground INSAR-derived ice content. So from satellite imagery, Sentinel imagery. So Simon created a draft figure to show, areas that are much ice rich, the red ones, and the green ones are ice pores, so less risk of ground subsidence. And so because the thing is, we can generate the scientific data, but how do we make it useful for people that are planning a new landfill site or a new subdivision, for example, or maybe in the case of a forced relocation. So sort of a first level resource for assessment and for planning to continue the study. So if you're interested and have thoughts on this, on what data and tools and how to present the data, we'd love to hear from you. Connect with me or anyone on the team. And we also have compensation available. So this would be available now, December and January. We'd love to hear from you. And yeah, I leave it right there with the Permafrost Discovery Gateway. And you are so very welcome to go and check it out. And we are, one thing I want to do, I haven't done it yet, is to put up a list on the gateway there of data sets that we want to add to the gateway, so that you are aware of what data we have on our radar, and you can complement and add to that list, because each data layer will become even more valuable with additional ones being brought in. So thank you so much, Steve. I'll end there, and I'd love to hear your questions.
Well, thank you, Anna. Really appreciate it. And we do have plenty of time for questions. So we'll both watch the chat, but also if you want to use the raise your hand function or just speak up, we again have plenty of time.
I think I have some team members here too. So I'll see if they want to add something maybe to the presentation here. So maybe Matt Jones or Bisu want to add.
Well, while we're waiting for folks to chime in here, I'm very interested in your partnership with Google, and two aspects of that in particular. One is, how was this initiated? How did you get up and running? Did you go to Google? Did they come to you? How does that work? But also the fellows portion of this. How does Google select somebody and then they come to you, or how do you first engage the fellows to be involved in this work?
Yeah, thanks, Steve. So yeah, this is my first project that was not federal money. So it's a new opportunity. And so Google.org had a competition out. So an open call asking for AI-based solution to address climate-related hazards. And I saw it 2 weeks before it was due. It was 2 years ago or so. And got thumbs up from everyone on the team, and we managed to get the application together in record time. And sure enough, they took the bait, Google, and it was a process there, probably about a half a year, going back and forth and refining, and them learning about what we were envisioning and us learning about them. So yeah, about a half a year later, we got the funding, and that we thought that was it. We got the money, $5 million. Woohoo! But then they said, would you like to have some full-time Google employees work with you guys? And we were like, wow, do you really? And so yeah, they said yes. So how about you put together a wish list of what you would like them to work on? So now we had to really think like big, and because we would have access to people full time. Because most of the time in academia, you work, a month on a project here and a month there. But these people would be full time with us for 6 months. And so we wrote our wish list, and we got actually help from two Google.org Google employees to help, so for us to understand how Google could help us. So this was through Google.org funded us the money, but then there is this fellowship program too that Google.org has. So if a Google employee see that the Google.org is funding a project, and the Google employee is like, oh, I'd love to work with that project and be involved in that, they can apply for a fellowship. And as long as they get okay from their supervisor on their regular day job, they can then become part of this fellowship. So we had, at the same time, I think we had about 12 people working at the same time with us. And then we had an additional 3 people working, part-time around that. So most of them were software engineers. We had user designers, end user researchers, and we still have 2 of them collaborating with us, even though the fellowship ended back in June. So this is just a wonderful bonus, big benefit of working with a big organization like Google, that they might offer more. And they also expanded the collaboration with Woodwell Climate through other opportunities too. So I think for an organization, whether it would be IARC or UAF, that Google is so big that there's other ways that they can collaborate with an organization as well to get that funding. So all of you, keep an eye for funding opportunities that might not be your typical path. They're out there.
Thanks. Yeah, very, very interesting to see in light of the incoming administration and what we can expect from them in terms of wanting more involvement of the private sector in research. So interesting to see how well it can work. And then we have a question from Matt McCander.
Yep. Yeah. Hi, Anna. So I guess my main question is: Are you using this for vegetation mapping yet? And what would it take to do that?
Great. We are not. There's no one that's doing in the development team vegetation map at the Pan-Arctic scale, and so that would be, if you have, I know you have algorithm for it, for the Maxar imagery. So if you would be interested to try out the tool that Visu has created, which builds upon Shande's, Pan-Arctic polygon mapping, you stick in your algorithm that is centering on vegetation mapping from Maxar imagery, then that workflow can help you try it out in different places in the Arctic first, and then when you're ready, you can apply for the whole big Pan-Arctic. So the workflow includes linking into different HPC resources too. So I think that's let's have a chat and see what's possible to do together on where you are and what your funding is and what our funding is, because I think that's the process now, and we definitely need people come in and try out the workflow that we generated, so that can also help give us feedback on how to make it even easier and better to use in future.
And is there a requirement for NSF funding, or can it be other federal funding, or what? Can you talk about that at all?
Yeah, I think it depends on the computing resource that we would use. So right now we have NSF funding until September, and so we have been using quite a bit of NSF supported HPC, and then now we also have Google. So we have a little special. That's another perk that I mean didn't mention, Steve, is Google can give you a bit extra help on the computing side as well. So we do run this near real-time lake drainage detection algorithm is Google Earth Engine, and as for example, and we also got Google Cloud Platform support from Google as well. So yeah, that would be part of the discussion, figuring it out and what the possibilities are. And Matt, looked like you were speaking up, Matt Jones, earlier about the fellows or the Google. Did you have something?
Yeah, I just wanted to say, like, I was pleasantly surprised by the um how effective having a 6-month fellowship was. The Google engineers onboarded to a totally new domain for them, like this whole focus on permafrost modeling, but they were incredibly effective over a very short period of time, and it helped really accelerate our project. So if any of you are contemplating, applying to some of the Google programs, I would highly recommend the fellowship program as something that I was somewhat skeptical that, somebody could come on board, sort of learn our infrastructure, learn our project, learn our science, and then contribute in a 6-month period. But they were absolutely amazing. So it was really, really valuable experience. We missed them already. So.
Yes, indeed. And they left us with, directions for the years ahead too. So especially the user designs of the tools and the website, we have guidance that they left us with there, for example. So their work continues for us. Their contributions are still with us throughout this project. Thank you, Ed. Yeah, so looking through the chats to see if there was something there. Good. Yeah, the downside, I'd say, with funding from some of these private or good.org is, NGO, is that the overhead rate is lower. So that's something institution would need to be okay with instead of your regular federal overhead. Oftentimes these overheads are 10% level, so it requires more commitment from your institution to support your project. But then if you think about the big picture with the fellows and the computing and everything, is yeah.
So any other questions? I'm not seeing any hands raised, but you can just chime in again if you have something. Then maybe just one last question from me, Anna. Are there any critical data sets that you see that are missing from the gateway? Something in particular that we need? I appreciate what you're saying about having so much data available right now that it's almost too much, and we have to concentrate on serving that and making it discoverable. But I was just wondering if you have anything off the top of your mind that we're missing that we as the IARPC community could address.
Yeah, thank you for the question. So if our science product is going to become really helpful for the real world, we need to have data of infrastructure and property lines and all of that digital format. And there's so many places in Alaska where the digital data does not exist, or it exists, but it's offset enough that FEMA cannot work with it when they get an application asking for emergency funds. So we need to help Alaska build up its infrastructure data so that our science data can be used to help people as they apply for money, to address their permafrost thaw challenges. So that would be, I think, the top of my list of data that's needed. And I know it's like Gary Greenberg, he's has his company in Kenai, and he's working with some Alaska communities, teaching them how to build their own digital infrastructure data sets. So maybe that's a model that can be copied and it also put the ownership in the people in these communities, and they know their data, they have control of it as well. So because the infrastructure mapping that Elias is doing is good for kind of statewide analysis, but when it comes to more detailed data applications for individual communities, I think you will need a different kind of digital infrastructure data.
Yeah, and I'll just add to that, Anna, that we have identified a lot of data sets that we think would be great to mobilize and make available. So I think our current list is maybe 75 additional data sets that are large scale that we've identified, and that we have not yet been able to invest the time and resources in getting totally up online. So we're working on trying to make that process more efficient, but we're always looking for help. So yeah, there is a lot of, I think, identified need that we haven't been able to meet or get incorporated yet. So I think Anna and Emily have been curating a list of data sets that we could share with folks if they're interested, that we have interest in. And new ideas would be welcome.
Yeah, because we really want to get to the point that when someone submits a data set to the Arctic Data Center, that in that data submission process, you check a box and say, yes, I want this data to become available on the Permafrost Discovery Gateway or the Glacier Discovery Gateway. And there's a workflow in the background that automatically processes the data and make it ready for visualizations. Because right now, so a lot of Matt's team is working on that back-end workflows. And right now, the data sets we have up there have been manually uploaded, and we learn a lot in the process of manually putting them up there. And I think it's also important, as new data sets are being uploaded, that especially the new ones, that the creator of those data sets are part of making sure that thumbs up on how the data is represented in the gateway, whether it's about the color coding or the brief description of the data. Because I think that's something too, when we scientists submit data, we write the metadata with a mind of reaching another academic user. We might also, I think we also need to write an abstract, a description of the data for let's see, the service provider of a remote community in Alaska, so that people know the limitations of the data. For example, the ice-rich polygon data set, this is there's more ice-rich polygons out there than what has been mapped, for example, so people know that there's underestimation of where they are.
Great. Well, thank you so much. Any other questions before we transition over to Meredith?
I want to say, just one last thing. So my goal is that I hope that people have their data, that they just can't wait to get it up to the Gateway or the Arctic Data Center, because suddenly they can work more with the data themselves, or other people can work with the data. So it's you become part of this bigger family, collaborative family, as you get your data up there, and yeah, enjoy the party of creating more good products out of your original data.
Great. Well, thanks so much, and thanks also to the team for joining us today. So with that, I'll pass it back over to Meredith for announcements.
Thanks, Steve, and thanks, Anna. it's been a joy to work with you, and you're so collaborative, and that's very evident here in this work too. I will put a link in the chat to everyone on the team. All the members of the team, you are welcome to suggest through this form any topics that you want to see covered at future risks and hazard mitigation team meetings or at any of the other team meetings. So if you have research you know about or have done, or a topic that you think would be good for us to cover, please use that form, and we will work to cover it in some way. I'd also like to share that IRPIC has yesterday released the new implementation plan for 2025 to 2026. I'm going to post a link in the chat to that new implementation plan so you can see there's a lot of continuity between the last 2-year implementation plan and the current 2-year implementation plan for teams. But there are some changes and differences as well, and new deliverables. And so I encourage you to explore that document and just know that we are now moving forward with a new 2-year implementation plan. And the recording for this meeting will be posted perhaps by the end of the day today, and if not, it will be posted next Thursday. So thanks everyone for joining. Okay, with that, I'm going to close this out. Bye.